Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a portion of distributed forces. So you must first master derivation of formulas for volumes, areas and arcs or lines, and also familiar with them. And this part will be to enhance your thinking skills, especially in locating centroids of volumes, areas, and arc lines, which are necessary later in analyzing a system with distributed forces. Level 61 problem, compute the volume of the concrete arc dam. So here is the cross section, and the arc dam is to be revolved about the vertical axis here through an angle of 60 degrees. So it's not one revolution. And the angle 60 degrees is pi over 3 radians. So for the analysis, because this cross section is, we have an inclined trapezoid. So we consider this as rectangle, then triangle, then we subtract this triangle also. So volume equals volume 1 plus volume 2, then minus volume 3. Volume 1 is the volume generated by revolving this rectangular section. Volume 2 is the volume generated by this triangular section. And volume 3 to be subtracted is the volume generated by this triangular section also. So that's it. So we revolve this rectangle, then triangle, then we subtract this triangle here, the excess. So this is 53. 36 plus 18 is 54. Since the thickness is 2 meters, so the centroid is 1 meter from the left. So 54 minus 1 is 53 meters. So volume by Pappus-Guldino's theorem is area times distance traveled by the centroid. The distance traveled by the centroid is radius of revolution, in this case 53, times angle of revolution, which is pi over 3 radians. So volume is volume 1 plus volume 2, this volume here, minus volume 3, this triangle to be revolved later. Volume 1 is area, which is 2 times 30, then times pi over 3 times 53, or 53 meters, radius of revolutions, times pi over 3, the angle of revolution, which is only 60 degrees or pi over 3 radians. So it is 1060 pi cubic meters. Volume 2 would be this triangle here to be revolved. The dimension of this triangle at the base is 18 minus 2, 2 meters. Then the distance of the centroid from the axis of revolution is 36 plus 2/3 of 16. Remember, this is only 16. So that centroid is 36 plus 2/3 of 16. So volume therefore is area, which is 1/2 of 16 times 30 times quantity 36 plus 2/3 of 16 times pi over 3. So volume 2 is 1/2 of 16 times 30 times 36 plus 2/3 of 16 times pi over 3 radians. So volume 2 is equal to 11,200 pi over 3 cubic meters. Then for volume 3 to be subtracted, the dimension is 9, base, height 30, and the distance of the centroid is 54, 36 plus 18, 54 minus 1/3 of 9, 3, so 51. So volume 3 is 1/2, 9 times 30 times 54 minus 3, or 51 meters, times angle of revolution pi over 3 radians. So volume 3 is 2295 pi cubic meter. So we can now compute the volume. Volume 1 plus volume 2, 1060 pi plus 11,200 pi over 3 minus 2295 pi. So in decimal and to four significant figures, 7,849 cubic meters. Level 62, determine the ratio B over A for which the volume of the fill equals the volume of the material removed from the conical excavation. Assume that the fill is axisymmetric about the excavation. So that's why we have here alpha and alpha here. So take note that this is the cross-section of the excavated material from this conical excavation, and the volume of this fill is equal to the area times distance traveled by the centroid around the top of the conical excavation, and the area is 1/2 this base, which is B minus A. Height, let's call that h1 later. Then the radius of revolution is the distance from this axis to that axis there, which is A plus this distance. So this distance is half of the difference between B and A. So A plus B minus A over 2. This is B minus A over 2. So the idea is, let's call that H, and the height of the conical of the material pile is H1. So that from the figure, this is B minus A over 2, half of the base of this triangular pile. So volume of fill equals volume of cone. Then by similar triangles, H1 as to B minus A over 2 equals H as to A. So H1 is B minus A quantity times H over 2A. 2 B minus A times H over 2A. Then substitute here. Volume of fill is area, which is 1/2 B minus A times H1, and distance traveled by the centroid is 2 pi radius of revolution. The radius of revolution is A plus this value B minus A over 2. So 1/2 of B minus A times H1, which is B minus A quantity times H over 2A. Distance traveled by the centroid is 2 pi times radius of revolution. The radius of revolution is A plus B minus A over 2. Then the volume of cone is pi radius square pi A square times height divided by 3. So simplifying, this is B minus A quantity square. Let's cancel out H. B minus A quantity square over 4A. Then cancel pi, distribute, times 2A plus B minus A equals A square over 3. So after we cancel out pi and H. So B minus A square divided by 4A. We distribute 2, so 2A plus B minus A. Then we have A square over 3. So expand this value. This is A plus B. Then cross multiply. So B square minus 2AB plus A square times A plus B equals 4/3 A cube. Distribute AB square minus 2A square B plus A cube, then plus B cube minus 2AB square, then plus A square B, which is this, equals 4/3 A cube. So AB square, and we have negative 2AB square here, so negative AB square minus a square b after we combine these two terms, then plus b cube equals 4/3 a cube minus a cube is a cube over 3. Cross multiply and simplify. Negative 3ab squared minus 3a squared b plus 3b cube equals a cube. Then 3b cube minus 3ab squared minus 3a squared b minus a cube equals 0. So using the calculator, which is acceptable for cubic functions, then we can solve b. We can express b in terms of a, and the only positive root where b is expressed in terms of a is 1.702a. Therefore, the ratio b over a can now be found. It is 1.702. So that's it for this problem. Level 63 problem. The aluminum cylinder is attached to the steel hemisphere. Find the height h of the cylinder for which the center of gravity of the assembly is at G. Use specific weight 76,840 newtons per cubic meter for steel and specific weight of 26,070 newtons per cubic meter for aluminum. So here's the given figure. Then for the solution, the centroid of the hemisphere is 3/8 from the base. So 3/8 from here. 3/8 of 225 mm. Then the centroid of the aluminum cylinder is h over 2 above G. So for the weight of hemisphere, it is specific weight of hemisphere, which is made of steel, 76,840 times volume of hemisphere, which is 2/3 pi r cube. So 76,840 2/3 pi 0.225 meter cube over 2/3 pi 0.225 cube. So it is 1,833.30 newtons. For the weight of aluminum, it is 26,070 times pi 0.225 square times height, assuming height is in mm, so we divide by 1,000 to convert it to meter. So 4.14625 h. Remember, h is in mm to be consistent. So the principle is because the center of gravity of the assembly is at G, the moment of the aluminum about G is equal to the moment of the mass or the weight of steel about G. So 1833.13 times 3/8 of 225 equals 4.14625 h times moment arm h over 2. So from there we can solve for h. H is 273.1 mm. Problem 64. Level 64. The assembly is formed by joining a semicircular steel, specific weight 77 kilonewtons per cubic meter, steel plate to a triangular aluminum plate with specific weight 26.09 kilonewtons per cubic meter. Both plates are homogeneous and of thickness 3.175 mm. Find the coordinates of the center of gravity of the assembly. So here is the given figure. So the assumption here is x, y, and z would be the reference axis that coincides with the centroid of the plate, thickness of the plate. So meaning to say, if the thickness is 3.175, the xy plane, for example, cuts the thickness into halves so that we don't worry about the z coordinate of the plate. It is 0. For the semicircular plate, it is cut by the yz plane. So that's the assumption, of course, because it is not emphasized here. So that the x coordinate of the centroid of this semicircular plate, which is made of steel, is also 0, the x coordinate. So for the solution, remember weight equals specific weight times volume. So let's just consider specific weight in newtons per cubic meter multiplied by 1000 because we anticipate that the weight is small or of low value. So weight of triangular plate is specific weight of aluminum 26,080 newtons per cubic meter. Then the volume is 1/2, base 0.225, height 300 mm or 0.3, diameter, then thickness 0.003175. So weight of the triangular plate is 2.795 newtons. Weight of the semicircular plate, which is made of steel, is 77,000 newtons per cubic meter times pi over 2 times 0.15 square times 0.00375, the thickness. So weight of the semicircular plate, which is made of steel, is 8.640. Therefore, the weight of the assembly is 2.795 plus 8.64, and that is equal to 11.45 newtons. So by Varignon's theorem, the x sub c of the triangular plate is 1/3 of 225. So it is this distance, 1/3 of 225, so 75. The y coordinate is 1/3 of 300 because that's 300 mm, so 100 mm. And the z coordinate, as I said, the xy plane cuts the thickness into halves, so 0. Then for the x coordinate of the semicircular plate, it's made of steel, 0, because the plate lies on the yz plane. The y coordinate is 150 mm from origin to here, and the z coordinate is this one, centroid of a semicircle, 4r over 3 pi, 4 times 150 divided by 3 pi, and it is 63.66 mm. So applying Varignon's theorem, weight of the assembly times xg equals weight 1, weight of triangle, x of triangle, plus weight of semicircular plate times x of semicircular plate. So 11.45 times xg equals 2.795 times 75 plus 8.640 times 0. So xg can now be computed. It is equal to 18.33 mm. 11.45 yg is equal to 2.795 times 100 plus 8.64 times 150. So yg is equal to 137.8 mm. Then 11.45 times g sub g is equal to 2.795 times 0 plus 8.64 times 63.66. So g sub g is equal to 48.10 mm. Locate the center of gravity of the hammer if the mass of the steel head is 0.919 kilograms and the mass of the hardwood handle is 0.099 kilograms. So this is the figure. This is the top view. We had an elliptical part here, which is occupied by the hardwood handle. So we'll consider this as volume of hammerhead 1, this triangular wedge as volume of hammerhead 2, then the volume occupied by the wooden handle, which is elliptical in cross section, is volume of hammerhead 3, and the volume of the handle, of course, is volume of hammer of handle or wooden handle, where the mass is 0.099. So volume of hammerhead 1 is 90 mm, 90 by 30, then perpendicular to the board 40, so 108,000 mm cube. Then for this part, 1/2 of 45 times 30 times perpendicular to the board 40 mm. So 1/2 of 45 times 30 times 40, 27,000 mm cube. Then for this portion occupied by the wooden handle, it is volume of ellipse is area of ellipse pi AB times depth or height 30. So pi 15 by 12.5, half of these dimensions, times 30. And it is treated negative, it is to be removed. So negative pi 15, 12.5 times 30, so negative 5,625 by cubic mm. So volume of hammerhead is 108,000 plus 27,000 minus 56,000, 5625 pi. So it is 117,328.5 cubic mm. So mass of hammerhead 1 as to its volume equals mass of hammerhead 2 as its volume to the 7,000 equals mass of hammerhead 3 as to 5625 pi equals mass of the entire hammerhead 0.919 over the volume of the entire hammerhead. So mass of hammerhead 1 is 0.8459 kilograms. Mass of hammerhead 2 is 0.2115 kilogram, and mass of hammerhead 3 0.1384 kilogram. Then the mass of the handle, wooden handle, is 0.099 kilogram. So the mass of the assembly is 0.919 plus 0.0990. So it is 1.018 kilograms. Then by Varignon's theorem, xg is 0 by symmetry. By symmetry, x sub g is 0. The center of gravity lies on this y-axis here, and therefore xg is 0. Then mass 1.018 times yg equals 0.8459 times negative 15, because this is 90. Half of 90 is 45. So this is the z-axis, this is the y-axis. So the centroid is 15 mm to the left of the y-axis or the z-axis. So that's why y sub c1 of hammerhead 1 is negative 15 plus mass of hammerhead 2, this triangular part, is its centroid is y coordinate, y sub c2 is 30 plus 1/3 of 45. 30 plus 1/3 of 45, 30 plus 15, so 45. Then minus, this is the mass of hammerhead 3. The centroid is here, so it's 0. Then for the handle, 0.099, the centroid lies here, so that's why y sub c4 or y sub c of the handle, wooden handle, is also 0. So solving for yg is negative 3.115 mm. Then 1.018 g sub g is equal to, so for the first hammerhead, it is 15 mm, half of 30 above the y-axis. For the wedge, 1/3 of 30 is 10. And for this assembly, it's 15. And for the handle, this is 210 divided by 2, 105. Then 105 minus 30 is 75. So 75 mm below the y-axis, the location of centroid of the handle. So this is, as I said, 75 mm. So it's G sub C of the handle, wooden handle, is negative 75. So 1.018 yg, G sub Z is 0.8459 times 15 plus 0.2115 times 10. This 10 here, as I said, is 1/3 of 30 for this hammerhead 2. Then minus 0.1384. The centroid of this portion is 15 mm above the y-axis. So that's 15. Then for the handle, 0.099 times negative 75. So solving for G sub G is equal to 5.209 mm. So that's it for this series of problems.